Okay. Alright, so let's look at what we call electronic configuration. So electronic configuration shows the arrangement of electrons around the nucleus of a shell. One importance of electronic configuration is that it helps us to determine what we call valency. We'll look at that later on. But I want to understand what electronic configuration is. It shows the arrangement of electrons around the nucleus of a shell. So we know that every atom has electrons, but the electrons are arranged in a particular way. So if you take, let's say, carbon here, the electronic configuration of carbon is 2,4, and it is 2,4 because if you take a carbon atom, if this is the nucleus, the first shell around the nucleus will take 2 electrons, and the second shell, which has a maximum capacity of 8, will take 4 electrons. And you'll notice something, that the number of electrons that an element has, if you check here, is 6. The proton is also 6. So the number of electrons is always equal to the number of protons, and which is also the same as its atomic number. So obviously here carbon has atomic number 6 because hydrogen is 1, helium is 2, yttrium is 3, beryllium is 4, boron is 5, carbon is 6. So when you know the atomic number, you can easily use that to help you get the electronic configuration. How is that you can just use the number and then you split the electrons. Take note, the first shell would always take 2. So assuming I'm given an element, it has atomic number 12, what I need to do is to split the electrons, which are 12, such that the first one is 2, because the first shell takes 2, the second shell will have to be 8, and I'll be left with 2 more. So it means that its electronic configuration will be 2A2, and that's magnesium. You can take an example like sulfur. Sulfur has the atomic number 16. So it means that taking the atomic number also is a way of identifying atoms or elements based on the number of protons. So if an element has atomic number 16, what that implies is that it also has 16 protons. Take note, proton is a particle in the nucleus of the atom. So if an element has atomic number 16, then it has 16 protons in its nucleus. And it's interesting to note that the number of protons an atom has is always equal to the number of its electrons. And we can see from here, proton number is 3, number of electrons is also 3. If it's 2 here, it's 2. See that clearly here on this table. The number of protons always equal to the number of electrons, and the number of protons is the atomic number. So 16 here, if you have 16 electrons, so we split them such that the first shell will have 2, the next one will have 8, because that's the capacity of the second shell. Then the remaining electrons will be on the last shell, and so we'll have 2, 8, 6. Okay, so that's how to write the electronic configuration for elements. Another example is calcium. Calcium has atomic number 20. So if it has atomic number, calcium is written as C, capital C, small a. Atomic number 20. what will be the number of protons? Number of protons would also be 20, because we said the atomic number is simply the number of protons. So if calcium has an atomic number of 20, it means that it will have 20 protons. And as we can see here in this table, realize that the proton number is always equal to the number of electrons. So if calcium has 20 protons, then it would have 20 electrons. Now to write the electronic configuration, take note, we said you split the electrons into the various shell. So we said the first shell, which is just, that's the closest to the nucleus, would always take 2. The second shell will take 8. So after doing that, that will be 10. We left with 10 more. So you do a third shell, which will take 8 also.